Hello friends, welcome to this tutorial on formatted output in Python. When we start learning Python or any other programming language for that matter, our initial programs generate very simple output. This output may be a few numbers or strings or a combination of both. For example, the output may be a message telling whether a given number is prime or not. It may be the sum, difference and product of two numbers. It may be the data of a student or of an employee. There may be many more such examples. In such programs, our focus is only on the logic of the program and not on the look of the output. We only want that output should be correct. But as we move to bigger and real-life programs, the look of the output also matters. In such programs, besides being correct, the output should also be presentable and easily readable. For example, let us assume that we have to display a report showing this data of some students. This report can be shown in many different forms, like a report in raw format to display the data as it is, or we can show different sublists in different lines, or we can show it as space separated values report, or comma separated values, or tab separated values. Observe that none of these reports is in a good readable format. The tab separated values may seem to be readable, but the problem with this report is unsynchronized column headings and the corresponding data values. Also, the data values go out of sync when some very big or very small value like a big name appears in the data. Now have a look at the same data displayed in this format. This is a nicely formatted report. The formatting has improved the look and the readability of the report. You can observe this. We may have to generate such reports in many programs, especially in the project work. Examples may include the salary slips, the marks lists, the bills for some items sold, the data stored in a file, the data from an SQL query, etc. In this video, we are going to learn how to generate such formatted reports in Python. There are two obsolete ways to generate formatted output. These are, first, using modulo operator to create formatted reports. For example, this code produces this output. Second, using format method of string object. For example, this code produces this output. Both of these are obsolete methods. Therefore, we shall not learn these. We shall learn the FString method to produce formatted reports. This method was introduced in Python 3.6 and is the latest and the easiest method till date. An FString is a string preceded by the letter F, like this or like this. Notice that F can be small or capital. The string may be with double quotation marks or single quotation marks. The string can also be a multi-line string like this or like this. An FString may contain some expressions within braces. Each such expression is usually followed by a format specifier. Format specifier is optional. During runtime, these expressions are evaluated and substituted by their respective values. A very simple example of an FString with the data is given here. During runtime, the expression a with braces will be substituted by the value of variable a. For example, consider this code. During runtime, the expression a with braces will be replaced by its value, that is 10, so this output will be generated. It is as simple as that. As another example, consider this code. In this code, the FString with the name rect will be evaluated during runtime. The expression name will be replaced by Afsana. TH will be replaced by 65. PR will be replaced by 29. And the expression TH plus PR will be replaced by 94. That is 65 plus 29. So the output generated will be this. Let us now go a bit deeper to see how to generate this report using FStrings. To generate such formatted report, first we have to design it manually. This is done to calculate the minimum column width required for each value and the total column width of the report. For this report, we observe that the field roll number has a column width of 3, the field name has a column width of 20, sex has a column width of 3, aggregate has a column width of 3, aggregate percent has a column width of 5, result has a column width of 4, and also there is an interfield gap of 3 columns. Total width of the report is 53 columns. Here we should be clear that minimum width of a field is calculated keeping in mind the width of the column heading and width of the corresponding data value, whichever is more. For example, for the field 6, the heading is 3 columns wide and the data value is 1 column wide only. So the field width of the report is taken to be 3. Similarly, for the field name, the heading is only 4 columns wide, but the data value can be up to 20 columns wide, assuming that the longest name allowed in this report is 20 characters long. So the width of this field is taken to be 20. It goes that way only for all the fields of all the reports. To start with, let us see how the heading of this report can be displayed using an FString. Here is the code. Let us understand this code statement by statement. The first statement declares a variable gap as a string of 3 blank spaces. This is used to specify the interfield gap. This way we can easily change the interfield gap whenever required. We can easily make it more or less, and we can also change it to some other character other than blank space. The next statement is a single statement spread over 2 lines. The backslash at the end of first line is a symbol of continuity of the statement to the next line. In this statement, we are declaring an FString with the name heading. This FString has to be understood properly to understand the output generated by this. In this FString, the first field specifies RNO to be included. 3s is the format specifier for RNO. Here 3 specifies that this expression, that is RNO, will have a field width of 3 columns, and s specifies that this expression is a string. The colon is the separator between the expression and its format specifier. Here we notice that RNO is a string of 3 characters only, and thus the format specifier 3s is redundant. We can skip it also. But it is always better to be explicit. We should always give it. The next field is gap. It will be replaced by its value, that is a string of 3 blank spaces to insert the interfield gap. The next field specifies name to be included. 20s is the format specifier for name. In this, 20 specifies that this expression, that is name, will have a field width of 20 columns, and s specifies that this expression is a string. The colon is a separator between the expression and its format specifier. Here we notice that name is a string of 4 characters only, and its width is specified to be 20 columns. So the remaining 16 columns will be left blank to the right of name to complete the column width of 20. This is the logic behind FStrings and the format specifier. It will be clear as we complete the code to generate the complete report. Similarly, it goes for all the other fields in the heading. The next statement displays the top line of the report, that is, this double dashed line. The next statement displays the FString heading. The next statement displays the dashed line after the heading. This way we can display the heading of the report. Now let us see how to display the remaining part of the report, that is the actual data values, using FStrings. First I shall explain the FString for the first record only. It goes exactly the same way for all the other records. So here is the code to display the first record. In the first statement, a variable data is used to store the record as a list. In the second statement, we are declaring an FString with the name rec. This FString contains data 0 3D. It specifies data 0 to be included. Data 0 is the roll number, that is 1 for the current record. 3D is the format specifier for data 0. Here 3 specifies that this expression will have a field width of 3 columns, and D specifies that this is an integer expression. Next, data 1 20s. It specifies data 1 to be included. Data 1 is the name, that is Sakshi Sahni for the current record. 20s is the format specifier for data 1. Here 20 specifies that this expression will have a field width of 20 columns, and S specifies that this is a string expression. Although this name Sakshi Sahni is only 12 characters wide, but to provide for the longest possible name in this report, we are printing every name in a column width of 20. Data 2 3s. It specifies data 2 to be included. Data 2 is the sex, that is F for the current record. 3s is the format specifier. Although sex field is a single character, that is F or M, but the heading sex is 3 characters wide, so we shall print sex value in a column width of 3. Data 3, 3D. It specifies data 3 to be included. Data 3 is the aggregate, that is 482 for the current record. 3D is the format specifier specifying that aggregate marks field is an integer to be printed in a column width of 3. Data 4, 5.1f. It specifies data 4 to be included. Data 4 is the aggregate percentage of marks, that is 96.4 for the current record. 5.1f is the format specifier. Here 5 represents the total width of the field, including the decimal point. Point 1 specifies that this value will have 1 digit after the decimal point. F specifies that this is a floating point expression. Data 5, 4s. It specifies data 5 to be included in a field width of 4 columns. Here data 5 is the result, that is pass for the current record. Gap, to insert the interfield gap. The third statement displays the FString rec and generates this output. So this way we have seen how to display the heading, how to display a record. Now we can move on to see the code to generate the complete report. Here it is. The first part is declaration of list containing data as a nested list. The second part is to display the headings that we have already seen. The third part is to display the actual data. Right now there is no need to revise the second part, that is to display the heading, so we can skip it and focus on the remaining part of the code. In this code, the for loop will iterate through the elements of the list starting from the second element, leaving the heading. And for each iteration, the current record will be stored in the variable data. The loop body contains 2 statements. The first statement in the loop body creates an FString with the formatted data. This FString contains data 0, data 1, data 2, data 3, data 4 and data 5, all with the corresponding format specifiers. It also contains the interfield gap. The second statement in the loop body displays the FString. So, the loop will pick the data from the list element by element starting from the first record, create the corresponding FString and display it. The last statement displays the dashed line at the end of the report. The output generated by this part of the code is this. So the output generated by this complete code is this. In this report, notice that by default the string values are left aligned and the numeric values are right aligned in their respective field widths. This report can be improved by center aligning the sex field values and by right aligning the heading for aggregate percent. Python provides a very simple way to align the data in FStrings. This can be done by using the alignment code characters, which are less than symbol for left alignment, caret for center alignment, and greater than symbol for right alignment. The alignment code character, if included, has to be the first character in the format specifier. Let us see the desired changes in the code for these alignments. For right aligning aggregate percent in the heading, we put a greater than symbol in its format specifier. For center aligning sex field values for each record, we put caret sign in the format specifier. With these changes, the output produced by the code is this. This way, by using FStrings, we can easily produce nice looking reports. The secret behind formatting is the format specifier. In the format specifier, we specify these 3 things. First, optional alignment code character, which can be less than symbol for left alignment, caret for center alignment, and greater than symbol for right alignment. By default, the text is left aligned and numbers are right aligned. Second, the field width. This field width is minimum field width provided to display the data value. If the value needs more width, it will take. In the case of floating point values, the field width is inclusive of decimal point itself and the precision, which is the number of digits after decimal. For example, 8.3f specifies that the number will be displayed using a total width of 8 columns, out of which 3 digits will be after decimal. One will be the decimal point itself, and the remaining 4 digits will be before decimal. Then comes the data type character, which can be S for strings, D for integers, and F for floating point values. The data type character is optional, but we must specify it at least for the floating point values. Otherwise, we may get some error or data may not be displayed properly depending upon the data value. So this much is sufficient to generate most of the simple reports and to create SQL queries with variable data. Continue watching the video to learn a bit more. There are some more concepts involved in formatting the reports. The first concept is padding. Padding is filling of unused width of a field. For example, when a name of 12 characters is displayed in a width of 20 columns, then remaining 8 unused columns are filled with spaces. This concept is called padding. And the space is default padding character. You can observe the padding in this report. Sometimes we want to fill this unused space with some other character rather than space. In general, this needs to be done to prevent the misuse of blank space in printed reports. In a format specifier, we can specify a padding character. For example, in this code, the string book is to be displayed thrice, each time using a field width of 10 columns. The first occurrence is left aligned with an asterisk as the padding character. The second occurrence is right aligned with a $sign as the padding character. And the third occurrence is center aligned with # as the padding character. This code generates this output. Padding is also applicable to numbers. For example, this code will give this output. If a padding character is included in the format specifier, it must appear as the first character and must be immediately followed by the alignment code character. We should be careful to place the padding character correctly before the alignment character. For example, this code will give an error because alignment character appears before the padding character. Another useful concept in formatting the output is comma separator for thousands. To increase the readability of large numeric values, we can insert the comma separator in numbers. Observe this code to display a number using an FString. This code will generate this output as expected. Now if we put a comma just after the column width, then the number will be displayed like this. Observe the commas as 1000 separators in the number. Comma separator itself can also be the format specifier without the mention of field width, precision, alignment or padding character. For example, this code will generate this output. Comma separator can be used with integers also. For example, this code will generate this output. Comma separator can be used along with other formatting characters also. For example, observe this code, it will generate this output. Another useful concept in formatting the outputs is %sign. It is used to treat the numbers as % values. For example, if you want to display 427 by 500 as 85.4%, then you can use %sign in the format specifier. It takes the value as a percentage and multiplies it by 100.0 in the resultant string and also puts a % character after the value. For example, this code will generate this output. When we specify %sign for percentages, we cannot specify F for the format specifier because %sign automatically takes the number to be floating point number. For example, this code will result in an error because %sign and F both are specified in the format specifier. Let us take a few more examples with %sign. %sign always treats the value as a floating point value. Here you see we gave integer only, but it has been displayed as floating point number. %sign can also be combined with comma as 1000 separator. Another useful concept in formatting the outputs is leading ± sign. By default, a negative numeric value is preceded by a minus sign, but a positive value is not preceded by any plus sign. To force a plus or minus sign before a numeric value, we can include plus sign in the format specifier. Observe this code. The output produced by this code is this as expected. Observe that negative 10 is preceded by a minus sign, but positive 10 is not preceded by any sign. By default, only a negative number is preceded by a minus sign and a positive number is not preceded by any plus sign. To force a plus sign before a positive number also, we can use plus sign in the format specifier. For example, this code will produce this output. The last concept that I am covering here is the truncation of strings to the given width. It has already been mentioned that the column width specified in the format specifier is the minimum width for the field. If the actual data value needs more than the specified width, then it will take. Let's take an example. For example, this code will give this output. Here the name Raghunandan Sharma is a string of 18 characters. Therefore, in the first case, when the specified width is 20, two columns are filled with the padding character. But in the second case, when the field width is 10, the complete string is displayed using 18 columns because the name does not fit in the specified width of 10 columns. Now let us take an example of a floating point number. This code will generate this output. Notice that according to format specifier, there is a provision of 2 digits before decimal and 2 digits after decimal. But this number has 6 digits before decimal, and so it takes 6 columns before decimal. But the number of digits after decimal is taken precisely as specified in the format specifier, that is 2 digits in this example. Therefore, dot in the format specifier is also called the precision specifier, and the number after dot is called the precision of the value. This concept of precision is also applicable to truncate the strings. For example, this code will generate this output. Notice that how the name has been truncated to 10 characters only. This is due to the precision specifier, that is dot, specified in the format specifier. This way, FStrings give us a lot of flexibility to display the data as desired. This flexibility is provided with the help of format specifiers for the data. For the basic formatting, we have covered alignment code characters for left, center and right alignment, field width for strings, integers and floating point numbers, data type characters for strings, integer and floating point types. This much is sufficient to generate simple formatted reports. And for the advanced formatting, we have covered padding, comma separator for thousands, percent sign to treat the numbers as percentages, forced plus minus sign before numbers, and truncating strings using precision specifier. With all these concepts, we can create almost all kinds of formatted reports which are needed at the beginner or intermediate level. Thanks for watching the video. I hope this is a useful video for all the learners. If you liked the video, please click the like button and share this video. Also subscribe to this channel and click the bell icon to remain updated about my new videos. Bye bye.